Okay, so when we talk about exponential functions in standard form, you've graphed these types before, so it's not going to be brand new to you. But we are just going to kind of reevaluate what all of the variables stand for. So in standard form, your exponential equation looks like this. Y equals a times b to the x minus h power plus k. And the good news is, like we just came off of the conics chapter, the good news is in most of the equations that we learn in math, the variables have very common, if not the same, implications on the graph. So like typically, when you think about a parabola in vertex form, stuff like that, x minus h, how does that affect your graph? And in terms of transforming it up, down, left, right, stretching it, flipping it, all that kind of good stuff, how does x minus h affect your graph? Very good. Left to right, so that's going to be your horizontal shift. And it's opposite of what we think it is, right? Like if it's x minus 5, that actually means we're going to the right 5. And if it's x plus 4, that actually means we're going to the left 4. And as you can probably guess, k then is going to be our vertical shift, up and down. What do you think a does to the graph? Yes, so it does both of those things. You're very right. It can stretch or compress. And then depending on if it's positive or negative, it can also reflect. And particularly it will reflect over the y-axis. No, I take that back. It will reflect over the x-axis. Okay, B in this case, before I write it, I want you to look at these two example graphs that I have over here. So out to the right, if you notice the one, y'all's aren't colored, but mine are. So if you look at this first one, you've got this blue curve here in the middle, y equals 4 to the x power. And then as we just talked about, the vertical shift plus k. So if you take 4 to the x plus 2, it shifted it up 2 and got the red curve. 4 to the x minus 3 shifted it down 3, you got the green curve. What is the value of b in all of those equations? 4, okay. In the second group of graphs, notice I have a downward curve now, or a decay curve now, except this green one. The green one on the bottom is a little bit different. But what do you notice about the b values in all of these graphs?
1/5.
They're 1/5. So key difference is, it's not just that one's a fraction and one's not a fraction. The main difference is that in the first group of examples, b is greater than 1. So if b is greater than 1, that's where we're going to experience growth. If b is between 0 and 1, that's where we're going to experience decay. And then this green function down here in the middle, that has the negative a out front. So that's where it takes a decay function and then reflects it over the y-axis. I'm sorry, the x-axis. Okay, so b tells us growth or decay. Now, traditionally, when you make a table of values, like in your head, you just plug in a number for x and you kind of simplify the whole expression, and then you get your output value for y. And it's kind of exhausting. So, like, don't write this down, but just think through this process with me. If I asked you to make an x and y t-chart for this equation for number 1, and I said, okay, let's plug in an x value of 2. I want to know, what is the corresponding y value going to be? So if I plug in 2 to x, let's simplify that exponent. What's 2 minus 2? 0. What's 2 to the 0 power? 1. 1 times negative 4 is negative 4. And negative 4 minus 2 is negative 6. So that was pretty simple. But if you plug in like a negative number, so let's plug in negative 2. Then we're going to get, so negative 2 minus 2 is negative 4. What is 2 to the negative 4th power? That's the same thing as 1 over 2 to the positive 4th. So what is that? Zach, did you say 1/16? Okay. 1/16 is this part. Then times negative 4 is going to be negative 1/4. And then negative 1/4 minus 2 is going to be negative 9/4. So doing that mentally is a lot more of a challenge. So I'm going to show you it's a new method. I just was exposed to it recently about how you can make a table of values. And it doesn't just work for exponential functions. It works for any functions. You basically start off with your core x and y. Okay, except when you plug in x, your second column is going to be whatever b to the x power is. So that's going to be the central part of our chart. And then basically what you're going to do is go through each one of the variables that affects the graph in some way and apply that to either your x or your y coordinates. So like horizontal shift, it's kind of given in the name, but does that affect your x values or your y values? Your x values. So what we're going to do is you're going to take your x values that are in your left column, and remember I said it's opposite of what we think. So when you have x minus h, that means technically h is a positive number, but then you subtracted it in the standard equation. So to the x values, you're going to add h to those in order to get your new x values, whether it's shifted to the right or to the left. A takes care of stretching and compressing, and if it's reflected over the x-axis, which means this affects our y-coordinates. So my y-coordinates start off with evaluating b to the x power, and then from b to the x power, we're going to multiply that times a, and then after you multiply it times a, the last aspect of the equation is a vertical shift, which obviously affects your y values again. So then with these numbers, you're going to add k. And then so basically what happens is all of the numbers that end up in this far left column are going to be your x coordinates to the ordered pairs. And all of the numbers in the far right k column are going to be the y coordinates to the ordered pairs that we're going to graph. Last thing I want to talk about before we do an example are asymptotes. So the parent function of an exponential looks like this. And there's an asymptote here at y is equal to 0. So horizontal asymptote at y equals 0. So basically, when we take our parent function and we do any of this manipulation to it, minus h plus k times a, we are shifting that horizontal asymptote up and down. So we're going to graph that aspect as well. Okay, number 1, all of the graphs, it says make a table of at least 3 values for each equation below, then graph the function and determine the asymptotes, domain, and range. So we're going to start off in like we did with this middle part of our chart, x in the first column, and then b to the x power in the second, except what value is b in this example? Two, thank you. So 2 to the x power will be in our second column. You can choose whatever values you want. However, I'm going to request that you at least choose a negative number, 0, and a positive number. And keeping them small is going to be better. So you're going to notice I pretty much will choose -1, 0, and 1 every single time. Okay, so we're going to substitute these values in. What is 2 to the 2? Oh, yeah, okay. So what is 2 to the negative first power? Very good, 1/2. 2 to the 0 power, anything to the 0 power is 1. And then 2 to the first power, anything to the first power is just itself. So 2 to the first power is 2. So that takes care of B. That takes care of your base. Then let's go ahead and manipulate our x coordinates. We said the x minus h feature was a horizontal shift. So if this is x minus 2, how is this actually shifting my graph? To the right too, very good. And it's opposite of what we think. So if it's x minus 2, it's shifting to the right 2. If I take all of my coordinates and I shift them to the right 2, then what I'm doing is I'm adding 2 to all of the x coordinates. So that's what we're going to do. Take the x coordinates in this column and add 2 to them. -1 plus 2 is 1. 0 plus 2 is 2. And 1 plus 2 is 3. Okay, so that's the only manipulation for the x coordinates. The a and the k affect the y coordinates. So then we're going to take our rightmost numbers, our initial y values, and multiply those times a. What is the value for a? So we're going to multiply by -4. So you're going to take these values. You always work from the inside out. So you take the closest values. 1/2 times -4 is -2. 1 times -4 is -4. And 2 times -4 is -8. And then the last part we have to take care of is plus k. Well, plus k is actually -2. So we're going to subtract 2 from these numbers. So -2 minus 2 is -4. -4 minus 2 is -6. -8 minus 2 is -10. So again, the leftmost column are all of the x coordinates of our ordered pairs, and the rightmost column is all of the y coordinates of our ordered pairs. So you're going to graph the following coordinates. 1, -4, 2, -6, 3, -10. So if you want, sometimes when I do this, I just put I cross out the 3 columns in the middle. That way I'm not tempted to use these values for anything. Before I graph these, well, let's graph these points first because we haven't talked about an example with asymptotes yet. 1, -4, so the 1 to the right, down 4. 2, -6. 3, -10. So I know those 3 points for sure are on the exponential curve. Let's talk about an asymptote. So we said earlier in the parent function, your asymptote is y equals 0. Well, when we shifted this, so let's think what we did. We shifted this to the right 2, which doesn't affect the asymptote because it's just going left to the right. We stretched it by 4. We flipped it over the x-axis, which, again, because the asymptote is the x-axis, doesn't affect anything. And then we shifted it down 2. So where do you think the horizontal asymptote is probably going to be for number 1? So loud. Did anybody answer? Okay. Very good, Sebastian. Y equals -2. Because you shifted your original parent function from where it is downward 2. So your horizontal asymptote will be y equals -2. So here's the scoop. For every single one of these questions, your asymptote is going to be determined by your k value. So your asymptote will always be y is equal to k. In this case, y is equal to -2. So go ahead and sketch that asymptote first. And then you're going to connect your points in such a way that the curve levels off here really close to -2. And then it takes off downward that way. In addition to your 3 points and the asymptote and the graph, I also am asking you for domain and range. Domain deals with x values. Which x values does this cover? All real numbers, right? It goes to the left forever, to the right forever. The range deals with the y values. So what is the lowest value that this graph will reach? All right. So negative infinity is the lowest part. -2 is the highest number it'll reach. Certainly you could have written this as a y is less than -2, but we use interval or we use inequality notation pretty frequently. So I want to just, for the sake of doing something different, use interval notation for this sheet.
That was my question I had earlier.
Which was what?
Whether we use less than or greater than with the asymptote. Everybody reached asymptote.
Yeah, so it would just be less than, not less than, or equal to. Yeah.
Greater than.
Right, or greater than. Yeah, because it's everything that's below that. Additionally, when we're using interval notation, we don't put a bracket, right? We put a set of parentheses because it won't actually touch that value. Okay, number 2. Start off with our charts. X in the first column, and then b to the x in the second column, except this time b, your base is 1/2 to the x power. Again, we're going to plug in the same 3 numbers, -1, 0, and 1. I'm going to plug in other numbers in a different example just to show you what happens, but to keep things simple, I would just keep using these 3. So when you plug these in, 1/2 to the negative first power. If you need to, go off to the side and kind of write what that looks like if you have a hard time visualizing it. 1/2 to the negative first power is the same thing as 1/1/2 to the positive first power, which anything to the positive first power is just itself, and 1 divided by 1/2 is 2. 1/2 to the 0 power is 1, because anything to the 0 power is 1, and 1/2 to the first power is 1/2. And you'll see a pattern, guys. Typically, when you choose a negative number and a positive number, one of them will be fractional and the other one will be an integer of the same number. It'll just be the reciprocal. Okay, so let's take care of the x coordinates. We've got x minus 1. Tell me in words, how is that shifting your graph? Okay, so if that's going to the right one, that means I'm taking all of my x coordinates and I need to add 1 to them. So we're going to take these x coordinates in that column and add 1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. And then the only other things we have left are a and k. Order of operations say we need to take care of the multiplication first. So we're going to take these 3 numbers, and then we're going to multiply them by a, which is 4. So 2 times 4 is 8. 1 times 4 is 4. 1/2 times 4 is 2. And then lastly, plus 2 means up 2. So that means we're going to be adding 2 to all of these numbers. 8 plus 2 is 10. 4 plus 2 is 6. 2 plus 2 is 4. So again, our outer numbers are going to give us our coordinates. 0, 10, 1, 6, 2, 4. So before we graph, where's the horizontal asymptote for this one? Very good, y equals 2, because the k value is 2. So sketch your horizontal asymptote there first. And then plot your 3 points, 0, 10, 1, 6, 2, 4. And then just make sure your curve goes through the 3 points that you've graphed, and then levels off as you get closer to your asymptote. Any questions so far? Okay, let's do another one. Except this time, I want to choose other values other than -1, 0, and 1 just to show you that you can if you wanted. So again, we're still going to start with x. B to the x power is the same as it was in the last problem. It's going to be 1/2 to the x power. Except instead of choosing -1, 0, 1, I'm going to choose -2, 0, and 2. So we're going to do the same thing. We're going to plug these three numbers into 1/2 to the x power. So 1/2 to the -2nd power. 1/2 to the -2nd power. In order to make this a positive exponent, we're going to have 1 over 1/2 squared, which, what is 1/2 squared? One-fourth, hopefully, you said or thought. And then 1 over 1/4 is just 4. So 1/2 to the -2nd power is 4. 1/2 to the 0 power is 1. And 1/2 squared is 1/2 times 1/2, which is 1/4. So again, you have that reciprocal pattern between one of them being an integer and the other one being the fractional. Okay, b is to the x plus 1 power. In words, how is that shifting your graph? Left 1, which means to all of your x coordinates, you are subtracting 1. So -2 minus 1 is -3, 0 minus 1 is -1, and 2 minus 1 is 1. Then we're going to take care of times a in our next column, which will be times -1/2. So 4 times -1/2 is -2. 1 times -1/2 is -1/2. 1/4 times -1/2 is -1/8. And then the very last step is plus k. In this case, it's -1. Therefore, this implies that our graph is being shifted down 1. So we're going to subtract 1 from all of our y coordinates. -2 minus 1 is -3. -1/2 minus 1 is -3/2. -1/8 minus 1 is -9/8. So these three numbers are -3, -3, -1, -3/2, and 1, -9/8. So there was no harm done in choosing numbers other than -1, 0, and 1. But the further you get away from 0, the larger some of your numbers are going to become, and they might be off of the graph, and the more fractional they may become, and it might be more difficult to actually calculate them. So to play it safe, I would always just choose -1, 0, and 1. Your asymptote, since k is -1, means our horizontal asymptote is y is equal to -1. And then we'll graph our points, -1, -3, -3, -1, -3/2, 1, -9/8. It looks something like this. Oh, and I forgot domain and range of the last question. Well, we'll knock them both out. Guess what the domain is going to be for every single exponential equation ever? All real numbers. You can plug in anything you want. There's no harm in having a negative exponent. Your range for number 3, the lowest it will reach is -infinity, and it will come all the way up to -1. Number 2 was an exponential decay question that was not reflected, so its lowest value will be at that asymptote at 2, and it will go up to positive infinity. Can you give me some sort of feedback about how you're currently feeling with like making this chart in order to graph and being able to do it without a calculator? Can I get a thumbs up, a sideways thumb, a thumbs down? Okay, have you ever seen this before? like doing a chart like this. So I hadn't seen it until I started tutoring some people that are going to different schools, and they were using this method, and I thought it was just kind of brilliant. All right, for the sake of time, we're going to skip over number 4. It's very similar to the other ones. If you want to do number 4 on your own and check it, if you plug in -1, 0, and 1, you should end up with the coordinates 1, 5 halves, 2, 4, and 3, 7. If you want to do that one on your own later. Number 5, the last graphing question, looks starkly different from the other ones because it just has fewer variables or fewer components to it. It's just f of x equals 2 to the negative x power. In fact, when we start off with like those initial columns of x and b to the x, it's just going to be 2 to the negative x power. There is no x minus h. There is no plus k. There is no times a. This is it. This is all that there is. So again, you can still plug in the same 3 numbers to start. -1, 0, and 1. And substitute those values into 2 to the negative x. So 2 to the negative x will be 2 to the negative first. Will just be 2 to the positive first power, which is 2. 2 to the negative 0 power is just 1. And then 2 to the negative first power will be 1/2. There is no k value. So as we said earlier, if your asymptote relies on your k value, then this asymptote is going to be at y equals 0. And then we plot these 3 points, -1, 2, 0, 1, 1, 1/2. You should get your curve that looks something like this. So that's essentially what's up with the graphs. Okay, the last one I need to talk about is different types of equations that we can use to solve for exponential growth, exponential decay, and interest. So for exponential growth and decay, hopefully you recognize this equation in some format similar to this from last year. We can represent growth and decay using the formula n, capital N, equals n sub 0 times, open parentheses, 1 plus r all to the t power. And in defining these variables, the first n just stands for your final amount. Just as it is within physics, anytime you have something with 0 as a subscript, it typically means initial. So n sub 0 stands for your initial amount. As you could probably guess, r stands for the rate, and t stands for time, or specifically the number of time periods. Okay, so if we look at number 6, suppose a researcher estimates that the initial population of a colony of cells is 100. If the cells reproduce at a rate of 25% per week, what is the expected population of the colony in 6 weeks? So let's just go from left to right, substituting values in for our variables. So n is our final amount. We don't know what that is, so I'm going to leave that as my unknown. Equals the initial amount of cells was 100. Times 1 plus, the rate is 25%, so the mistake that people make is doing 1 plus 25. You want to input 25 as a decimal. So 1 plus 0.25, all to the t power. Number of time periods is in weeks. There are 6 of them, so then it's going to be to the 6th power. So you just want to calculate 100 times 1 plus 0.25, all to the 6th power. We'll go ahead and round this to the nearest whole number. how many cells do we anticipate seeing after 6 weeks? Very good, Sebastian. About 381 cells. Now, I had mentioned earlier that on your test, I anticipate doing a calculator portion and a non-calculator portion. These exponential graphs, you need to be able to do without a graphing calculator. So you need to be able to just kind of know how to do the table and do all of that short mental math without a calculator, or if worst case, just the four function ones. These types of problems, you will be able to use a calculator on with decimal or exponents that are a lot higher than 2. Okay, last type of scenario is on compound interest. We can find compound interest or represent those scenarios with A is equal to P times 1 plus R over N, all to the NT power. And even though there are some different variables, the locations of them still kind of maintain the same function. So like A, even though it's different than N, this stands for your final amount. P, even though it's different than N sub 0, still stands for the initial, or in these cases, they might use the word principal amount. T still stands for time, particularly number of years. R stands for your annual interest rate. And N is the one that you just got to be cautious with. It's the number of times the interest is paid or compounded. Interest is paid, compounded each year. So the number of times the interest is paid or compounded each year. So they're going to use things like compounded quarterly or compounded biannually, things like that. So the last example I have for you here. Determine the amount of money in a money market account that provides an annual rate of 6.3% compounded quarterly if $1,700 is invested and left in the account for 8 years. So again, we're still solving for the final amount. So I'm going to leave A alone. That's our unknown value. P stands for the principal amount or the initial amount that they invested, which in this case is $1,700. Times 1 plus the rate over N. What is 6.3% as a decimal?
0.063.
Okay. All over N, which is the number of times the interest is paid or compounded each year. So if it's compounded quarterly, how many times is that in the year?
4.
All right, so that's 0.063 over 4, all to the N times T power. So you just told me that N was 4. Times, they said it's happening over 8 years. So T stands for 8. And you could calculate this piece by piece. You can say, oh, 4 times 8 is 32, and then do 1 plus 0.063 over 4, all to the 32nd power, then multiply that times 1,700. Or you can just plug this all into your graphing calculator at once. Just be very cautious using parentheses around that fraction. You use your little caret symbol to raise it to the 32nd power. And since we're dealing with money, and money is defined through the hundredth place, with cents, we'll round this to the nearest hundredth. Quarterly. So then that amount is going to be about $2,803.03. Yeah, there are 4 quarters and $1.